Fine. So, and I think yesterday we have seen about
composition versus
fine.
inheritance.
Yeah. And initially, yes, we just completed the inheritance part. Fine. That cuboid class. Okay. And where it was using inheritance, right? So cuboid as a case of inheritance, and where it was inheriting the instance variables, methods. Okay. Fine. Any constructors you will always have to specify in a subclass. Okay. Or else if you don't specify, what will it be? Fine, using super without any parameter, right? A no argument constructor will be there available for you. Okay.
Using as an object without superclass. Using as an object.
Using as okay, like okay, if you don't specify a superclass, yes, object becomes the superclass. Fine. Okay. And then so yeah, we also saw about method binding.
Yes.
Fine. Which happens. So which method will be invoked is not decided by the type of the variable. Fine. When we use a particular variable and a method, right? Which method will be invoked is dependent on the object. Fine. So it is decided at runtime. Okay. So we say method binding for methods. Okay. Method binding is done at runtime. Okay. And then for variable binding, when we saw the concept of a shadow variable, right? Okay. When superclass has a variable instance variable, same name, another instance variable may be having you may have in a subclass, and we call it as a shadow variable. Okay. So variable shadowing may be done, but in such case again the variable binding is done with based on the type, that is at compile time. Okay. So variable binding at compile time, whereas method binding is done at runtime. Okay. Fine. And
instance of operator.
okay, we use the instance of pattern matching, right? We said pattern matching using instance of, right? So yeah, because we were using lot of casting operations between superclass and subclass, and cuboid, rectangle. Okay, yeah, we were having some rectangle object. The variable was a rectangle type, but it was having an object of cuboid, right? So we were trying to use cast in order to use anything which is specific to the cuboid. Okay. So yes, if you want to have casting to be done, fine. A safe casting would be to do a check whether actually it is an object of the specified type or not. Okay. And for that, yes, we have seen that we have an operator called instance of. Fine. So we were using instance of, and then within the so we would have a if statement, and within the if statement you would have instance of, right? Okay. When you would do a casting, right? Within the block of the if, you would do a casting, right? So you may declare a local variable for casting by doing a cast and then use it. So in such cases, right, we have a new feature by which we call it as pattern matching, basically. So when we say pattern matching, yes, it's like when we use the instance of, we'll declare a variable for a local variable for the specified type for which we are checking. So we'll say, okay, oh, it's some variable or some expression instance of, and then you have to specify a reference type. Okay, also specify a variable name, and you can follow it with specifying the local variable. So it's like it's doing a cast for you and making it available in the variable. Okay, and that casting will be done conditionally, like only if it is instance of the type. So it's that local variable is only the scope for the local variable is only within the if state, fine, if condition. Okay, that if block if you are having. Okay, and so that we had seen yesterday, right? Okay, and then we saw about composition when defining a cuboid as a composition. So cuboid has a rectangle, right? When we were using inheritance, we said, oh, let's extend from rectangle, cuboid defined by using extension from rectangle. So at that time, yes, what we were doing was we were thinking of it as being a is a relation, right? Is a not a correct relation for in case of cuboid and rectangle. So cuboid is not a rectangle, right? And therefore we should not have gone for inheritance. Okay, the relationship is has a relation, and therefore we have composition, and we would go for composition in such a case. Okay, fine. So yeah, fine. So we again redefine the cuboid class, fine, where it was using rectangle as a instance variable, right? Okay, and then yeah, and then yes, a few comparison of inheritance of composition. Which would be preferred? We would prefer composition unless we find there is strictly a is a relation, right? Unless we find is a relation, and we should be going for composition, right? Okay. And yeah, the advantage with composition, what's the advantage? Methods, yeah, you get full control on the methods. Okay, what methods? It's your decision, right? Fine. Okay. Okay, yeah, and then we said, oh, let's have both the versions of cuboid. Yeah, we wanted to have both the versions of cuboids. So what did we do? Yeah. So have a, we would like to have a prefix. So that's to make them unique. The name should become unique, right? So there must be a prefix, fine. And to have a prefix for the types you define in a Java file. So Java file is used for defining a type, fine, that we know. Okay, so for the types which you are defining in a particular Java file, okay, you can declare a prefix. Okay, you want to have a particular prefix, okay, and that is what is specified with the help of a package statement. So we have a package declaration statement. Okay, fine. uh, okay, unlike the name of a class, when we define say class and followed by a class name, right, that class name would have only single identifier. Okay, fine. Whereas a package name may have multiple identifiers separated by a dot. Okay, fine. So and that's something which we can do. Yeah. Okay, let's just check. Let's open the file. Now what I had to do yesterday was I think we didn't save it at that time, right? Cuboid.java we had saved. We have our own original cuboid.java which was using inheritance, and this is the one which uses inheritance. Okay, and we had used a prefix, right? We had declared a package. Okay, when this was done, we had defined the other file, but yesterday I think in a hurry we didn't save it. Anyway, I saved it later. But yeah, okay. So what I did was, so how would I have saved it? I can't have it in the same place. So created a new folder, fine, and then saved it in that place. Okay. So what I have done is I have put it in a folder called in SRC. Right? All source code is in SRC. Under that, I just created a COMPO folder and put the cuboid.java. Right? See, this has no relation with the packet declaration which we have. Okay, there's no such relation. Okay, anyway, if you try compiling cuboid, you will be getting errors, okay, for a reason, and which is different from saying, oh, it's not because of the packet declaration alone, there are other things, and there is something called access specifiers, access modifiers, which you may use with the various things which you are defining. See, what are we defining so far? What are the things you define? You define types. Fine. Okay. Types are your classes, interfaces, enums, annotation, record. Okay. So you define them. So as soon as you say, I have a class called hello world, fine, a data type called hello world becomes available. Okay. By using a packet declaration, what are we doing? By having a packet declaration, what do? We only give the prefix to the name. Okay, if you don't have a packet declaration, then what? No, we were not having packet declaration. So what was it? Every type which you have belongs to some or the other package. Okay, even if you don't declare a package, there is actually a package called the unnamed package. Okay? We have a package called unnamed package. So when we don't make a packet declaration, they all go in a common package called the unnamed package. Okay. Fine. I don't know if you recollect when we had generated the documentation, we did Java doc, right? On second or third day, we did that, right? So at that time, the documentation which was generated was mentioning about the unnamed package. Okay, it was saying, oh, we have an unnamed package in which all of these have been created. Okay, fine. So everything belongs to some or the other package. Fine. So package is always there for everything, right? Okay. So we have 5 kinds of members for a package. Package has 5 kinds of members. Okay. Let's see this now. Anyway, before we move forward, any questions so far? Yeah. Any questions up till now? Yeah. Yeah. Okay. Yeah.
Sir, if we declare different packages, different prefix in
Yeah,
both cuboid file,
Yeah.
why do we require to save the cuboid file in the different folder? Because we already
Otherwise, we'll be overwriting that same file. We are having a physical file by a name cuboid.java in a particular folder. That was src folder. I wanted to save the file name. Of course, I could have given a different file name. Okay, maybe you want that? Yes, we can do that also. Let's change the file name instead of putting it in a separate folder. Okay, fine, and let's see. Okay, yeah, we can do that also. That's not a problem. Okay. Okay, so yeah, maybe we can change it. So this one, this cuboid.java, right, which is using composition, I have saved it in a folder called compo. Okay, let me do a save as and remove the earlier one. Okay, let's put it in a okay, so in the same place. Okay, and giving a different name. Okay, so what do we want to call it?
cuboid composition.
Okay, cuboid composition.java. Okay, or you want to call it cuboid 1, cuboid 2, you can do that also. Okay, so cuboid1.java. Right? See, our class is not public. It's fine to have a file name not matching the class name. Okay, and we are not making our class public. Okay, fine. Okay, and we wanted to have it removed. We don't want the folder called compo. Okay, so under SRC we don't want the folder called compo. So let's go and do that. Okay, so go to the and we have the compo folder. We have cuboid1.java, right? Okay, so we'll be having, so we can just and so that's gone. And so we fine. Okay, so we have two classes. Of course, they will have to be in a separate Java file. Fine. So one Java file has the cuboid class using inheritance. The other one we have called it as cuboid1.java, and that's having the one which is using composition. Okay. Fine. Okay. Fine. So now we were talking about the package thing, right? So let's go back to that package thing, and then we'll of course have to do some 10 other things. We'll see what is required to be done. Okay, so now see, it's something like this. We have a package, right? We have some kind of a package. Okay, so we have a package, and so that's some kind of a package. Oh, you can have multiple package, right? So yeah, we may have another package. Okay. Okay. This is the one which uses inheritance. There's a package for that. There's a one which is using composition, a separate package, and there's that unnamed package also. Yeah, we have things which are not part of any package. We didn't make a packet declaration, right? Okay, fine. So now we understand that as what are the members which go in a package? So in this in a package, you may have a class, interface, enum, annotation, or a recorder. They are types. Okay, fine. They are all types. Okay, so when I'm saying, oh, I want to have a class called cuboid in a particular package, yes, I have a type whose name is having that prefix. Okay, and there is a dot cuboid, something dot cuboid. Okay, whatever the package name you have decided. Okay, so that's just a type. Okay, fine. Now, where can this type be used? Who can use this type? Okay, so I'm talking about access specifiers now. Okay, we are now looking at access specifiers. See, we never used, so far we have never said, oh, we have a public class. Okay, no, none of our types was public. Fine. For members of a package, remember, I'm talking about members of a package. What are members of package? They are only types. Okay, for members of a package, we have only two kinds of access specifiers. What are the two access specifiers? One is the default. When you don't specify anything, okay, that's different from saying something about it. Okay, so they've used, okay, if you don't use anything, oh, that also has its own meaning. Fine. It's not by default it will become public or it will become private or any such thing. So in Java, for access specifier, default has a separate meaning. Okay, fine. So for members of a package, we have only two access specifiers. Either it can be public. Fine. Member of a package can either be public or it can be default, not mentioned. It's not private. Okay, it's not saying private, not saying anything. Don't mention access specifier. That's our default access specifier. Okay, fine. It has its own meaning. Okay, so yes. So what do you think happens if I declare a class to be public? What does it mean? Yeah, it is usable outside the package also. Fine. You have defined the class called cuboid as part of a package. Okay, the package is geometry.shapes. Okay, let's say, so we have a cuboid class or even the rectangle class. Okay, so we have this geometry.shapes. Okay, so here is, let's say, geometry.shapes. That's a package, right? Member of that, oh, there's a member called rectangle. Okay, so what does it mean? Geometry.shapes.rectangle. Fine, the name actually is geometry.shapes.rectangle. That's the name of a type. Where is this geometry.shapes.rectangle available currently? What do you think? What is the scope? It is default, therefore it should be available only within the package, not available outside the package. So if someone writes a code here, maybe there is some other class in this other package, and he says, well, I'm interested in using geometry.shapes.rectangle. No, it's not available to you because you are not part of the same package. Okay, so it's about the types. Members of a package are types. Okay, so this type, someone wants to declare a variable of type geometry.shapes.rectangle. Oh, you are outside the package geometry.shapes, you cannot be using it. The type itself is unavailable. Fine. Okay, fine. So we know one kind of things. Okay, we have the types which are member of a package, and they can either be available as part to only within the package by making them default, or they are available to all by making them public. There's no other option for members of a package, and I'm using the word members of a package. Okay, because yes, I'm not saying class. Why? Because class are not only members of a package, they can again be members of another class. We haven't studied about it, okay, but we know we have nested types also. You can have a class definition as part of some other class definition, but it's still a type. Class is a type. Fine. Class, when I'm saying class here, I'm just giving example of a class. It's those 5 types. Okay, so they may be appearing as member of some class. So if it is member of a class, no, we are not talking about that, oh, only 2 access specifier for a class. Okay, we are not saying only 2 access specifier all classes. It's for members of package, right? And then we had seen about what are the members which go in a class definition. What are the members in a class definition now? So here is a class rectangle. What kind of members do we have in the rectangle class? We have got instance variables and the class variables. So those two are the variable types. Okay, variables, and maybe static and non-static. Okay, then methods, again static and non-static. Constructors, right? Okay, fine. What else was there? We had the class initializer block, But can anyone be using the class initializer block? There's no need of someone to use the class initializer block. It's used only by the class loader, Java class loader. So there's no question of a access specifier for such an item. Initializer block also were there, right? But there's no question of having a access specifier for the initializer block because they become part of a constructor. So you have got access specifiers for the members of a class. Which members? Variables, right? Methods, constructors, and there can be the nested types. Okay, and at this moment we are not going into the nested types, but whatever we are talking about access specifier, they apply to members of a class, right? They'll apply to members of a class, all members of a class. So we are not looking at the local variables or the parameter variables. They don't apply there. They apply to the members of a class. Access specifiers apply to member of a package, member of a class, member of an interface. Yes, everywhere access specified. But we are talking about those members. Okay. Okay. So coming to members of a class, yes, we have the variables, methods, constructors, and subtypes, nested types. Okay. So for them, for members of a class, there are 4 access specifiers. And we have got 4 access specifiers for members of a class. Okay, which are those 4? So a member of a class may be, and we can start with the narrowest thing, most narrow. Okay, so the narrowest access specifier is the private, and it can be private, and second one is the blank default. Okay, so we have been using the default all the time. We were not fine. We are not aware about the access specifiers so far, right? So now let's look at all of them, right? So one is private, second one is default, the third one is protected, and then comes the public. Okay, so that way there are 4 access specifiers. Okay, so they will be applicable to members of a class. So any member of a class may be declared to be either of these kinds. Normally, private is used for the variables. Okay, private is used for variables. Sometimes you may have a variable to be public also. Okay, so what's the meaning of private? What is the scope for private? Scope for default was package, right? Public was, okay, usable everywhere. Fine. Scope is full. But with default, for member of a package we saw, it was restricted to package level. What do you think should be the private one? Fine. The class level. Okay. So it's something like this. Okay. So member of a class. Okay. So if I have declared some variable or any kind of member of a particular class to be private, then it is not available to any other class. Okay, it's not going to be available to any class. Okay, fine. Or it's not available outside that class, rather, I should say. And I'm not saying, oh, it's not available to any other class. It is available to some classes, which may be the nested ones. Within this, within the class itself, you have another class, right? So that one will be able to see it. Okay, it's the scope is the, so anything private in a class will be available only within the class. It's usable directly only within the class. Outside the class, not available. Okay, we have written the class called rectangle, right? And then we have written a class called test rectangle. In test rectangle, we have created object like a rectangle R1 is equal to new rectangle, and then we said R1 dot length. Let me see the value of R1 dot length. Suppose length was declared as private, then that's a separate class. It's a class called test rectangle, right? So test rectangle cannot be using length, which is a private variable, if you declare it private. Okay, we haven't done that, but yes, that's normally what is to be done. Normally, your variable should be private, because the test rectangle may do something like, oh, let me set R1 dot length is equal to -5. Oh, we don't want to allow someone to just set up any kind of a value anywhere, right? Okay, you will have to set it through the set dimensions method, and in the set dimensions method I might keep that checked. And your updation to the state of the object should be through methods. No one should be directly changing the variables. Okay, fine. So your code is your class, the class is your code, right? Others are using it. Okay, fine. So you don't want someone else to modify your variables, and normally you would have methods through which, if at all you would like to allow the state to be changed, okay, that change can be only through methods which you provide. So you have control on how a particular variable can be getting modified. Okay, so fine, clear meaning of private. Okay, I'll explain one more meaning about the private thing itself, right? But this touches on the nested types. Okay, so maybe within this class itself, and within some class, we have a, okay, I'll put it here, so I have a bigger thing here. Okay, so we have a class over here in the second package. Okay, and that in turn, it has some variables which may be private. Then it in turn has another class definition. Okay, and this one also has some variables which are private. Okay, let me say I have a class A and a nested class whose name is B. So it becomes A dot B basically, because it's a member of A. That class is called A dot B. Okay, a private member of A is available, is accessible for within B, right? It is available within the class. When private member of A is available within the class A. Okay, now what about the private member of B? And you think it's not going to be accessible? It's accessible within B, that's one thing. Okay, you think it's not accessible in A? It is accessible in A. The private applies to the member of the package. B is member of A. What is B? It's member of A. A is the member of the package. So when we are looking at private, everything which is private in A is available in A. B, which is declared as private, is part of A itself. Okay. So from accessibility point of view, yes, this is going to be accessible. So if, for example, in the class A, someone creates an object of B and then tries to access the variable which is declared in B on that object, it will be available, even if it is private.
But we create object of A class.
You may have created object of A first, but see, the existence, that is one thing. The variables of B, instance variables of B, will exist only if you have created an object of B. Okay, so if someone has created object of A dot B, right? Suppose that the creation is happening with as part of the class A somewhere over here, right? Okay, so it can create object of B and then say, let me access that variable. Okay, fine. But you need first the object to be created. Okay. So always think in that manner. If there is an instance variable, you need, it is always part of an object. So access requires that you must first have an object. Okay. If you have object, that thing exists, and if it is there, it's part of A. It's considered as part of A. It's private to A. So private is with respect to the member of the package. Right? The private is not with respect to, when saying, oh, it's accessible only within the class. It's not with respect to the nested type. It is with respect to the member of the package. The nested type is not member of the package. It's member of the some other class, some other type. Okay. So private is private to member of package. Okay. Fine, clear? Private is accessible only within the class. Okay. Then what's the next access specifier? Default. Okay. So what was default in case of type? What was the scope? Package. So if a member is declared as default, okay, let's say here in the rectangle we have some, everything is default for us now. So where is it available? It's available within the package. Fine. Throughout package, anyone will be able to use it. Outside the package, it's not going to be usable. Fine. It's not going to be usable. Okay, not available outside the package for use. Fine. Even if it's a subclass, okay, remember this. Even if it's a subclass, yes, it's not available. Okay. So you got some variable over here which is declared as default. Maybe I have created, oh, we have that geometry.shapes as a package where we have a class called rectangle, and then we have a geometry.shapes.inheritance as the second package where we may have a class called cuboid which is extending from the rectangle class, right? Okay, it's extending from here. You have variables which you have declared as private. What do you think? Is the private thing available here? No. It is default. What do you think? Is it available here? No. Okay, fine. So private we understand, not available outside the class itself anyway. But if it is default, it's not available outside the package. Within package, anyone will be able to use it. Fine. Within the package, any other class or any code which is part of that package will be able to use it. Okay. Right. Clear? Default meaning is package level. What about protected? What's the meaning of protected? Yeah. What's the understanding about protected? If you have any previous understanding about protected. Protected means it is, yeah. Okay, so if you declare something to be protected, it is having the package level access. Oh, same as the default, right? Okay, so that's one thing. It is like a default with slight additional things. Okay, there's only slight change. It says, okay, like default within package, anyone should be able to use the protected member. Okay, so there is some other class here not related to this. A member declared as protected in rectangle, okay, will be available in that package to anyone. That was the case with default also. Okay, this is what was default. Additionally, if you got a subclass, right? If you got a subclass which may be as part of a different package, fine. So we have another class which is part of a different package. So we created a cuboid class, right? Right. In our case, we have done this. Okay. So if we have this cuboid class which is extending from rectangle, but this cuboid is not in the same package, then what will happen? A member declared as protected. Yeah. Is it accessible? Is it accessible? Right? Now here, many of the texts have mentioned this in a very loose language, in a loose manner. Okay, they would try to imply that it is accessible. The variable is not accessible outside the package. A protected member is not accessible outside the package, but it is getting inherited. What is inherited is available in that form. It is available in the inherited form. I'll write the point here, and I'll give the example exactly. Fine. What is not accessible here? What is meant by not accessible? Suppose this class which is outside the package, it is a subclass, but it is creating, so when it is a subclass, and suppose I have a variable x over here which is a protected variable, right? I don't have to declare x again in the cuboid class. It is getting inherited for me. Okay, so within the cuboid class, I will be able to use x on the object of cuboid. On the object of cuboid. Suppose I create an object of the rectangle class. Within cuboid, I'm having the object of, someone say, okay, you are writing a main method, some method here, and you're saying, oh, let me have an object of the rectangle class available over here. So there is some rectangle R1 which is done, and he says R1 dot X. No, it's not accessible on rectangle. It's accessible on cuboid, but not on the rectangle, because you are not in the same package. It inherits, X gets inherited. Cuboid inherits X. Within cuboid, I'll be able to use X. I can say this dot X. I can say even super dot X, because then it is on the object of cuboid. Okay, now I'm not able to access it on the object of rectangle. It's not accessible on rectangle. It's accessible because of inheritance. What you have inherited is accessible. It's not accessible on the place where it is declared as default, as protected. Okay, so protected is inherited. So it is available on the type which has inherited it. It's available on cuboid type. In cuboid, it will be available on cuboid type, but not on the super type. It's not available on the rectangle type. Fine, clear on this? Meaning of protected, fine. So because this has been misinterpreted in many places, fine. So many texts, they are not clarifying this aspect. Fine, so important to remember this. Fine. Okay, next. What is next? Which is the next access specifier? Public. Okay, so what do you think about public? Accessible? Anywhere, yeah. That was the case till Java 9, before Java 9. Okay, fine. So public is not remaining public any longer from Java 9 onwards. You declare public, yes, it is available outside the package. It is becoming available outside the package. Java 9 introduced a new concept. They introduced what we call as modules. They introduced the, right? So they added a concept of module. Okay, so what is a module? It's just to understand, right? Just a brief understanding about some idea about what is modularity about. Okay, so we can find. So we'll have to have a different picture altogether now. Okay, so what we have is multiple packages can be grouped into a module. Okay, fine. So you may have, you create package, you define so many packages, right? We understand we have packages and members of package are all of those 5 things. Okay, but we have a module. So maybe if you consider this as a module, okay, this is some module we have. Okay, fine. So that's a module 1, let's say, and similarly you may have a module 2 also. Okay, fine. We have a module definition, that is module info.java, specific file name to be used in order to define our modules. You define a module by using a specific file. See, I said in Java, you can only have 5 things, right? So what they have done is, okay, when we introduce a module, we said, okay, we use a specific file name and the name would be module info.java. Only this kind of a file by this specific name can be used to declare modules, to define modules rather. Okay, fine. Now each module, fine, is having as members. What are the members of a module? Packages. Okay, so you got one package which in turn has class and everything types. Okay, you got another package. So these are packages. Packages are the members of a module. Okay, so when we define a module, it's like, okay, there is a module, give a module name, and then we say, oh, we don't have to say anything. When you actually there is a directory structuring which is used in this case, and which will decide what are all the members of a, which are the member packages. Okay, now in a module info, what you will be declaring is that, okay, I use other modules. You are saying, okay, I require to be using other modules. I'm dependent on, I want to use classes from another module. Okay, so I want to use things from, okay, let's consider module 2 is being defined, right? So when module 2 is being defined, it is saying I'm using module 1. I need module, I require, okay, I require module 1. Okay, I'll say I require module 1. When it's a require, and so module 2 says, oh, I require module 1. Okay, but what module 1 has done, oh, it has so many packages, but then it says, okay, it says, oh, I export, and I'll say I export only so and so packages. So a module definition decides which packages will be available when someone is dependent on this module. Not all packages become available outside the module. So public member of a package, okay, a public member of a package is available outside the module only if the module has decided to export it. Okay, so from that point of view, okay, a public is not, public means, oh, it's not available to all. Public is available to within the module. Outside the module also, in case it is part of the package which is being exported by the module. So modules export packages, but module use modules. Okay, so module says, oh, I want to be using, I depend on a particular module. When it says I depend on a module, what will be available are the packages which have been exported by that module. So to module 2, okay, which says I require module 1, from module 1 only the exported packages are available. Not everything of module 1 becomes available. Okay, so modules have their own privacy. Okay, and something which will not be available outside the module. Okay, and their entire packages basically. Anyway, so from that point of view, yes, the meaning of public is, it's not really fully public now. Okay, but yes, if you're just looking at the modules within a module itself, oh, it's public is available throughout the module and available outside the module in case it has been exported, in case it's part of a package which has been exported. Okay, so access specifiers should be clear, and the 4 access specifiers for members of a class, and 2 access specifiers for members of a package. Right? Okay, now if you go back and try compiling the things, let's see what will happen. The kind of messages which you will get. सब नहीं, मॉड्यूल 1 का डेफिनेशन डिपेंड करता है. मॉड्यूल 1 बोलता है मैं सिर्फ पैकेज 1 दे रहा हूँ. So module 1 decides that it decides to export. So it is part of the definition of module 1, which will decide. If someone says, see, anyone who wants can always say, I will require so and so module. There's no restriction. You can mention any module because you want to use classes which are part of the packages available in a particular module.
How to decide model 1.
Huh?
That is only access model 2.
I didn't get, sorry.
मॉडल 2 को कैसे पता चलेगा कि मैं ये एक्सेस कर सकता हूँ मॉडल 1 का ये पैकेज?
हाँ, मॉड्यूल 2 को मॉड्यूल 1 का कुछ दिखेगा नहीं, एक्सेप्ट फॉर वट एवर इज एक्सपोर्टेड. कंपाइलर है ना, बैठा है ना एरर देने के लिए.
इसमें कुछ डिफरेंट होता है क्या? मतलब पहला पैकेज है जिसको एक्सेस करता है मॉडल 2, बट सेकंड पैकेज को नहीं ये करता, एक्सेस नहीं कर रहा है.
हाँ, अच्छा, मॉड्यूल 1 का डेफिनेशन है, मॉड्यूल 1 है, उसने लिस्ट दिया, एक्सपोर्ट पैकेज दिस, एक्सपोर्ट दिस पैकेज, एक्सपोर्ट दिस पैकेज. मॉड्यूल 2 जब बोलता है रिक्वायर मॉड्यूल 1, तो उसको कौन सा पैकेज दिखने वाला है? जो वो लिस्ट में है, एक्सपोर्ट किया है, उसके अलावा नहीं मालूम है उसको.
कॉल कराएंगे वही.
It's about using them, right? So you will not be able to use them. नहीं, इसको क्या देखेगा मॉड्यूल 2 को? उसने बोला आई एम डिपेंडेंट ऑन मॉड्यूल 1. See, I'll tell you why this modularity came. क्यों आया modularity? Why this modularity has come? Why do we have this modularity? Java became very large in terms of its library. The library was so huge. Now, you write a program which is required, which does not require a database, but the file, wherever you are installing, right? So it had a huge library file, single library file, which was very huge. It was called as rt.jar, runtime, rt for runtime. At runtime, all of these classes are available. I don't know what someone will be using. This is the entire library for Java, so many things, and every new version, so many new classes and everything was getting added. So it was a huge thing, right? Okay, size was also huge. And when someone says, oh, I want to use a particular class, okay, fine, from a package, oh, it's available, right? Everything was available. Okay, so one thing was a lot of things. It requires a lot of space. Okay, so this was one of the tasks which was taken, since we have devices which may have limited space. Okay, and also, if you have a large number of classes and someone says, oh, I want to load that class, it will have to search in a bigger space, right? Time consuming. Okay, so cutting the time of loading also, fine, as well as, oh, if it's I'm writing an application which does not need that, I want to distribute the application to someone, fine, I can say, okay, let me have a Java, let me have a smaller footprint of Java which only uses so and so modules. So there is one, so basically this modularity was for the Java library, breaking it into smaller parts, but keeping in mind that yes, if you take a particular part, it depends on some other modules. We have one of the modules called java.base, right? Where, so in java.base, yes, they have internal dependencies, they have, right? And java.base module has been created keeping in mind that yes, this is the minimum things which everyone will need. If you use anything in Java, yes, this is the minimum things you will be requiring. Okay, and then yes, you may not be using database related things. Okay, we have a module where the database related things are separated out. Okay, if you are distributing your application to someone, why do you want to distribute the entire big thing? Okay, it has to be deployed in a smaller device, right? It shouldn't be occupying too much of space. It was very huge thing, rt.jar. So they have done this job of breaking it into modules. Okay, it took a lot of time to break it into modules, keeping in mind the dependencies among them. Some package here depends on another package here, or they were using it all over the places. So things had to be getting organized. Okay, because dependencies have to be properly managed in this case. It's about managing the dependency of one class. And some class in a particular package was dependent on some other class in which all packages. So you depend on so many other classes, right? You define a class and you are defining a class called hello world, but you are dependent on, don't we use other classes within hello world? Oh, we depend on system class. We depend on the string class. Okay, the system class, we don't know what all it is using. Oh, it is using so many other classes in the definition of system. In the definition of string, oh, it is again using so many other classes. Right? So that dependencies have to be kept in mind. Right? Okay, so fine. So this was just to highlight the point that yes, public has no longer remained public. Okay, public means part of the available throughout the module. And anyway, as a developer, you normally will not be creating multiple modules. When you define an application for a single application, yes, you may not have multiple modules. Breaking into modules, yes, we don't normally do. It is mainly meant for, because we are dependent on the Java library where there are modules. Okay, they have broken it into modules because it's really huge. Right? You may be using some other framework which has got so many packages that they have again decided to put it into modules. Then yes, you should be aware of what modules you will be using. Okay, fine, clear? Okay, fine. So coming back to the access specifiers. Yeah, any questions now on access specifiers? 2 access specifiers for member of package and 4 access specifier members of a class. Yeah, we haven't yet seen into interface types. So when I'm saying class, yes, it's about the class types. Fine. So members of a class type. Class types are classes, enums, and records. So class, enum, or record, they have got, members of those will have 4 access specifiers. Okay. Declaring a variable private means we normally declare variables to be private. It would be applicable to if someone tries something like r1.length, right? Okay, do we want to allow that outside the class or not? Okay, fine. What about access specified to a constructor? Methods also we understand, but access specified to a constructor? See, each one has its own access specifier. I would like you to use the type, but I don't want you to be able to create the object by using new. I'll make the constructor private. Here the meaning is you can use this, you can use the class, you may, if you have the object of such a class, you will be able to invoke a method. You will be allowed to write a method which uses a parameter of the type rectangle. But no, creating a rectangle, I don't want you to be allowed for that, right? Maybe outside the package, I don't want you to create a rectangle. Okay. Here, accessibility to various members. Each member has a purpose. We have seen that purpose. Okay. So constructor has a purpose of allowing creation or not. So fine. Each thing is independent, right? Okay. So you are declaring a variable to be private because you don't want the access to the variable. But one thing, if the type is not available, then the members within the type have no meaning. You may have something declared as public, but the class is default. The class is default. The member of the class is public. Does it make sense? Does it remain public? The type is not available. How can the member of the type be usable? You are saying, oh, it's public, but yes, it will still not be usable because the type is not usable. Okay, class is not public. Class is only default outside the package. A public method of that class. Oh, we are not even knowing that class outside the package. Okay, and so such things, yes, you will have to use the common sense there and be able to understand that part. Okay, fine. Okay, so let's see the code which we have got. Yeah, so now what do you think here? Can we go for public classes at this moment? Okay, let's try with the minimum thing which will have to be public. Yeah, I think what we will need to do, the two cuboids are there, they'll be part of two different packages. Rectangle used in both of them. One is saying I'm extending, other is saying I'm having it, okay, as a member. So what should be done to the rectangle? Has to be available outside the package, right? Rectangle will have to be available outside the package. Okay, so here is rectangle.java. Okay, it is geometry.shapes. Okay, so we should make it public. Right? Okay, fine. Declare our class as public. What are the member like length and width? What do we want to do here? Variables, we should declare them as private. Okay, so let's make this thing private. Okay, okay, let's keep that also. Anyway, what about the variable here? Fine. Static variable also. Why should someone be able to access the count? The count is only updated from the, fine. The count is going to be updated only from the constructor, right? Okay. Static method. Okay, anyone wants to see the count? Fine, wants to know the value of the count. So getting the value of count, okay, let that be a public operation. Oh, static block, no, we can't say anything like public or anything to this. What about the static method? Oh, we have a method called testStatic. I don't know what it's for. We were doing something earlier. Okay, anyway, method is there. I'm just making it public. Here, I think it's not doing anything, right? We may as well have removed it. Okay, the block here, initializer block, it cannot have an access specifier. Oh, here's the constructor. Now, do we want to allow creation of the object from outside the package? Okay, fine. We would like to allow it outside the package and we would like to make it public. At this moment, yes, we are making it public. Right? But you may come across classes where constructor may even be private. Okay, so don't take it as a rule. The normal thing would be that methods would be public, variables are private, and constructors initially, yes, as you initially do something, yes, it would be normally be public, but in some cases, right, there are certain different type of patterns where you may like to keep it even private also. Fine, sometimes default, sometimes private. So for constructor, fine, don't apply that rule. Okay, fine, don't take it as a rule that all constructors should be public. Fine. So our initial part, yes, we are keeping it as public. What was this method to return the length? Oh, you want to know the length? Since it's only reading the value, we can make it public. Okay, let's make this also public. And area method, fine. Okay, so anyone will be allowed to find the area. Okay, changing the dimensions. Maybe do you want to allow change in the dimensions for the rectangle class? For everyone? You want to keep it only available within the package, something which is known to me? Fine, maybe. Fine. So you may decide to keep it. Even someone may like to keep it private also. Yeah. Or okay, let's make it public anyway. At this moment, let's make it public. But yes, you can decide, yes, I don't want the change in the dimensions. And so dimensions then becomes usable only as part of the class itself. So maybe we have used it in the constructor and no other place, right? We have used it only in the constructor, and therefore, yes, you may even say, okay, I want to keep set dimensions private, so no one actually changes the state of the object once it has been created. Once a rectangle is created with a specific length, and well, you don't want to allow changes to it. Fine, then you could have made it private also. Okay, it's being used from a constructor, so fine, we'll keep it. Okay, anyway, so we are currently, yes, we are just going ahead with making it public. Oh, we have toString method is being public. What about this class? The class called test rectangle. Okay, we want it public. This is not member of a class. This is member of a class. Test rectangle is member of a package. Which package? Oh, we have declared it at top. Geometry.shapes. Oh, do we want to keep it as member of this package? Or should it be on a separate package called test? We may have a separate package called test where it will be fine. So this class we may shift to another place. Okay, the file we want to keep it public. Yes, then we can keep it in a file by the name testrectangle.java. Okay, I'll cut it from here. Okay, and take it in a new file. Okay. Fine. So this is the entire thing which we have, but here we are making it package test. Okay, let's have a package test where we'll have the class called test rectangle. We'll have package test with the class called test cuboid. Okay, so test cuboid, test rectangle, oh, we'll make them as, and even the test account, oh, we make keep a separate package where we'll have all the classes for the which contain the main method. Okay, so yeah, now yeah, you want to make it public. Yes, we can make this class as public, and we will save it as testrectangle.java. Okay, and then we'll have to scrutinize this code here. Okay, oh, there's a lot of changes which will come in this code. Yeah, so we want to save it where? Here only. Oh, we have the testrectangle.java. Okay, fine, so we have separated it out, and the earlier class which was rectangle. Yeah, we need to save this also. Okay, we'll save this. So this, okay, let's see whether this code rectangle.java compiles or not. And rectangle.java should be compiling, right? Oops. Okay, so we have these files. When we are currently concentrating on rectangle and the test rectangle. Okay, so java c minus d dot dot backslash bin. We got rectangle.java to be compiled, and yeah, it compiles. Okay, what do you think will happen if I say let me compile test rectangle.java? Shall we compile or shall we just go through the class definition and see if we can find some problems which may arise? And let's go back and first let's have a first look at the class now, since it has become part of a separate package. It's not in the same package as the rectangle class, but we are going to be using the rectangle class here, right? Okay. Okay, so test rectangle. Okay, it's a public class. Yeah. Now here it says rectangle. Do we have anything called rectangle now? Do we have anything called rectangle available now? What is it? It is called? What is the name? We don't have anything called rectangle. We have got something called geometry.shapes.rectangle. It's not rectangle. The name has changed to geometry.shapes.rectangle. Okay. Fine. Same thing. Oh, here again, this constructor says new rectangle. There's no rectangle. It's geometry.shapes.rectangle. Right? Another place. Let's see this. R1.length here. R1 equals to new rectangle. Yeah, the constructor, this anyway will have to be updated, geometry.shapes.rectangle. Constructor is public and therefore new should be fine with me. Okay, R1.set dimensions, yeah, we have kept it public. Oh, this one. What is this doing? R1.length, that should be a error. Length is private. Okay, set dimensions is a public method. Here, what about this one? That should be working because the method is public. Okay, this one, that won't work. We should be using the method. Okay, fine. Anyway, so we realize there are some problems, but let's see what the compiler says. Okay. Okay, yeah, we were aware that yes, there are some problems. And have we been able to identify, oh, I cannot find rectangle. There's no rectangle, we understand that now. It is geometry.shapes.rectangle. And so other place is the constructor where we were calling the constructor. That other place is the count. There was that R1.length also, I think somewhere. Okay, that should all be errors. Anyway, so whatever error this is giving us, let's just fix only those. Okay. Yeah. So it says we have errors in line number 6, line number 9, 19, 20, and 21. Okay, so line 6 is here. Okay, line number 9. Which one? 19. Okay. Okay. Here, I think what we need to do is we need to call the method, right? Then variable is not public. Okay. Okay. So yeah, we fix those many, whatever it has mentioned. Let's try again. Oh, still 5 errors. Oh, I think what we are compiling is separate thing. Is different from what we have. Test rectangle.java. Okay. And this is what? Package geometry.shapes does not exist. Yeah, it thinks the geometry.shapes.rectangle doesn't exist. It is trying to look for geometry.shapes.rectangle, but where is it looking for that? When it comes across geometry.shapes.rectangle, it is now thinking, now see what the compiler is looking for. It is looking for a folder called geometry, containing the folder called shapes, containing the rectangle.java file. So one option is we move our rectangle Java file there. Another option is still there, and let's try the other option. Okay, when I compile this, I'll also say, okay, we have this rectangle.java also. You are dependent on this. So I have the rectangle Java definition, this file. Please compile both of them together. Okay, let's see what happens now. Oh, we have one errorless. We didn't change that new rectangle. Oh, that's for R2. Okay, but now you can see that error has gone. Oh, it has now come to length. Okay, fine. There's another error for, oh, that place again we forgot, geometry.shape.rectangle. Okay, so we have line 11, 19, 20, and 21. Okay, so we missed on. Yeah, so 11, yes, it didn't get error earlier, so we can change this. Okay, what was the next one? 19, or in between. Yeah, and it's all about geometry.shapes being not present. Yeah. Okay, so we are making it everywhere. Wherever we have used rectangle, we are saying it is geometry.shapes. Okay, let's compile it. New rectangle R2, 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 R2. Yeah. So this was line 20 again. Okay. Yeah. And it's compiling. How will I run this? Minus CP dot backslash bin. Yeah, no? Yeah. Test rectangle or
Rectangle.
it is test rectangle. It's not no longer test rectangle. It is test rectangle, and there it runs. There's no test. rectangle now. It is test.test rectangle. And clear? Okay. See, while compiling, what we had to do was give the dependent Java file here. The other option was we could have put it in a folder from where it could have been located. See, each time we were compiling cuboid, it was always compiling the rectangle also. Because we had in cuboid, we have reference to rectangle. Okay, therefore it would compile the other thing also. It will look for the other class also. Because if you are dependent on rectangle and you have been using things from rectangle, it has to know that whatever your usage is correct or not. For that, it will also need to have the class definition for cuboid, rectangle. So while compiling cuboid or something which is dependent on rectangle, in this case it's the test rectangle, it is also requiring the other thing. Okay, now one thing we have done is in this Java file, okay, we have used geometry.shapes.rectangle multiple times, right? Okay, you could have done one thing here. There is a statement called import declaration. So you could have done an import declaration giving this name. When you make an import declaration, what happens? Yeah, what do you understand by import?
It's just import somewhere.
Import means what? Yeah. The meaning of import?
Use fetch the data item.
Nothing like fetching or anything. See, this is something, it's not something which is for runtime anyway. This is for the compiler. It's an instruction to the compiler. In this Java file, if you come across rectangle anywhere, okay, if you come across this rectangle thing, please replace it with this. I have written rectangle instead of geometry.shapes.rectangle. It's simply a substitution to be made by the compiler. It's a declaration of a substitution. Compiler needs to substitute all rectangle declaration. Anywhere you have used the type simply as rectangle to be considered as geometry.shapes.rectangle. There's nothing like importing from some other place or something like that. Okay, it's not an action for runtime. It's a compile time action. It's just instructing the compiler. In this Java file, I have only used rectangle instead of writing the whole name. Okay, let's check this. So now, yes, now I can do like this. Yes. If I don't use the full names, oh, with so many places where to do it. Okay. This is still going to work. Or maybe even if I've written the full name, there's no problem. See, import is not a mandatory thing to use rectangle here. And that's the first thing we did. Oh, it's not rectangle anyway. To use geometry.shapes.rectangle, I don't need the import. Okay. If I use import, I'm saved from some keys. Right? I don't have to type so much. Okay, it's not about making it available, right? Okay, it's not that it's making the class available. Import is not doing that job. Availability is decided by the access specifier. Okay, it's going to be usable or not here. That's dependent on the access specifier. Import has no role in that. Import is simple substitution for the compiler. And a simple substitution rule for the compiler. Okay. Fine. We can compile again and we can run also. Okay, so it's working fine. Okay, fine. Okay, we'll see how exactly the compiler is making use of import. Okay, I just asked a question. I think that should be able to clarify what we are trying to understand here. Okay, but this is about import. Now I'm talking about import declaration. Fine. We saw what is the meaning of package declaration. It's nothing but a prefix for the types defined in a Java file. And what is the import? A substitution. How the substitution works? Okay. Now, okay, the question here is something like this. Yeah. Oh, we haven't yet done this exercise. We have just started with whatever we have done here. You will have to do it for the account class. Okay, account test account. Okay. Yeah. So maybe we have a class like this. There's a. Okay. So let's assume a file which has a package declaration. Okay. So we have some package one. We have a class called class one. Okay. Fine. So that's one Java file. And maybe as part of the same package, I've also got class called class 2. Or okay, in the same package, I declare a class called string. Okay, so we have package 1 having two classes, class 1 and class string. Okay, if I compile, what are the types created? If I compile this, what will be created? pkg1 dot class 1 and pkg1 dot string. Okay, it's fine to have a class called string for your own thing. Okay, you can always have that, right? Okay, now let me write like this. Suppose I write public static void main string array. And I put like this system.out.println. Yeah, okay, suppose something like this happens. So my question is, what about compiling this? Will this compile or not? First question, is this going to compile or not? Okay, it's going to compile. Okay, when I give the command pkg1 dot class 1, what do you expect? And we are executing, we say it is going to compile, right? Now after compiling, if I say let me run this application, what do you think happens? You saw the message when we didn't have a main method. What was the message? It said, oh, we need a public static void main method, right? With the parameter of type string array. That message will come. You'll get that message here. The reason here is, okay, you have not done an import. Anyway, the question of import even doesn't arise here. Even if you put some kind of an import, okay, here, when you have used string, the substitution of string will be it will be substituted as pkg1.string. My current packet declaration says pkg1. Any symbol I come across, it's not only string, anywhere else, any symbol, the compiler is working in this manner. Okay, I'm coming across some data type. Okay, here is a type name. It doesn't have a prefix, there's no qualifier to it. Therefore, how do I make a substitution? For that, I think this must be in my own package. That's why you have not written it. So it's thinking the string is part of my own package. That's why you have not written. And I find it is there. Oh, then it is pkg1.string. If this string was not declared, we don't have in pkg1, we don't have a string class. Okay, then what will it do? It would have compiled, but how is it going about the things? So first thing in any symbol is it part of the package? Let me try to use this as the prefix. If I don't find, okay, I will look at some import, maybe. Is there any import? Okay. And if this happens to be valid, it's not part of pkg1, but if this happens to be valid, it will substitute with this. If it can load a class called xyz.string, your declaration of string is substituted with this. But substitution would start, the import is taken into consideration, provided that is something, whatever you are using is something which is not available in your current package. First preference is pkg1.string. See, in this current case, this will still not work. You're saying, I want strings to be substituted with xyz.string. It won't do that. It will still be substituted as pkg1.string. You know, the string which we use is part of a package which we have been using so far, which is from the Java library. All things in Java library are some part of some or the other package. Okay. Yes, you have this package. This is basically, if you want this to work, it will have to be written as java.lang.string. We don't have string. In Java, there's nothing called string. It is actually java.lang.string. Okay. Right? We'll look at that substitution rule which is available. But anyway, we'll continue this tomorrow, right? Okay. So it's java.lang.string, right? That's, if you put this, yes, that's going to work. Everywhere we were using only string, but it is actually getting substituted by the compiler to java.lang.string, and how that substitution is happening, and we'll be looking at that. So we'll continue tomorrow. Okay. And then, yes, then we'll take up the exercise of organizing everything into a packages. So tomorrow, yes, we'll have that. Right? So tomorrow, yes, we'll do some exercise also, right? Okay. But package and other thing was access specifiers. Okay, that should be clear. Okay, so tomorrow, yes, we'll see that, and we'll have our code also updated to use all the access specifiers. We have done it only for the rectangle currently. Okay, but cuboid also has to work. Okay. Okay, fine.